Before looking at some examples, let's talk about our line integrals, surface integrals, and volume integrals in general. We're going to start with our line integrals, and our line integral is defined as the integral of the tangential component of some vector or vector field A along a curve L. So this is a little bit confusing, so let's look at a figure that will hopefully help us visualize this a little bit, and then we'll write out some mathematical definitions as well. So we have some vector field A in this case, and we want to do the line integral along the line from A to B. So how we would write this mathematically is we would say the line integral is the integral along the line of A, which is our vector field, dot dl. And now our dl is going to be whatever it is based on how we're moving along this line. So it might be, if we're talking about Cartesian coordinates to describe our problem, it might have a component in x, it might have a component in y, it might have a component in all three directions. So that's going to depend on our specific problem. So we could use our dot product and we could say we know this is the integral from a to b of the magnitude of a cosine theta times dl. And so this first one again would be read as the line integral of A around L. So line integral of A around L. Okay? And so what that looks like in terms of the dl and that cosine theta up on this figure is we would have some differential length if we're going from A to B. There's going to be some differential length along this line that we can talk about in this direction if we're going from A to B, and this would be our dl. And then of course theta, so I've not drawn that right on top of an A line, but our tangential component of A, we would measure from here to our A, so that would be our theta. So that's where that cosine of theta would come in. So now we could talk about a closed path. So what if we just close this path and we go back from B to A? And it doesn't necessarily have to be any particular shape. I've drawn it sort of simple. It almost looks like a circle, but it could be whatever shape. In this case, we would have, so let me indicate this is for our closed path. We would have the integral of L along L, so A dot dl like we did before. Now we're going to put a little circle around the integral here in the middle. And so what this indicates is that this is now the circulation of A around L. Circulation of A around L. And so that's just some terminology, not terribly important. And so let me do capital L there. And so this should actually be capital L up here as well. So just some terminology difference between a circulation versus just an open line integral. One other thing in terms of terminology is in the textbook, you'll see a lot of different terms to describe the same thing. You'll see line, you'll see curve, and you'll see contour. And so in the textbook, all three of these things are used interchangeably to describe some path along a curve in space.